So we ended our previous video by saying there were two issues with these prototypes that we put here. The first problem is the stack pointer. So it is true that we are giving the function a pointer to the first element. So this is basically the head, the pointer to the head of the list. But the problem is the push function will need to update the stack, and so will the pop function. It needs to actually update its position from this to the element it's going to create. So it's going to move it from this point to this point. But because when you pass an element to a function, and see what it does is that it creates a copy of it. It passes it by value. So suppose this was our stack that we're passing to the function. What we'll see do is it will copy it, create another pointer, which will point to the same first element, but it's just a copy of it. So what will happen is that your function is going to operate on this. Now it could follow what it points to and operate on this, and this is perfectly fine. This is our element. This is our element that we're going to modify, and this is perfectly fine. But the problem is with this particular stack, what if we wanted to modify it? We can't do anything to it because it hasn't been passed to us. We didn't get this version of the stack, this version of the pointer, we just got a copy of it. And whatever modifications you do to it, at the end of the function, they will be erased. And the stack will remain where it is, pointing to that element. So if you wanted it to point to another element, this won't happen. Even if you update this copy, bring it here, when the function ends its execution, this will just disappear. And this will remain pointing to the second element. So you haven't updated the stack. The way to resolve this is to pass a pointer to this pointer. So we're going to have a pointer to the pointer which points to this. So take some time to get your head around this. So basically what we're doing is now we have a pointer and we're copying this. So we're going to pass this copy to the function, but this will point right here. So we can always access it, modify it within the function, and even access this and modify this if we wanted to. But this will remain just as a copy, and then we don't really care about that, right? We could just discard it after this. But what we're basically achieving is we're achieving this point where we can now modify the stack itself. So the way to do this is to simply add a star right here. So now we have a pointer to a pointer, and similarly here in the pop operation. So we've solved our first problem where we couldn't modify the stack pointer. Now we could modify it however we want within the function, and these modifications will carry to the main execution or program flow. Now the second problem we said was relating to the pop function. We said that the pop function needed to return two things. It needed to return an error code if there's anything that goes wrong, and the second thing it needs to return is it's the data itself. So it's actually popping something and it's returning a data. How does it do that? Well, what we're going to do to solve this problem, there are multiple ways to do it. You could, for example, return null whenever there's a problem, and in this return value, keep one return value, return null if there's a problem, and otherwise return the data itself that you're popping. But what if we had null as part of the values? What if our values could actually store null? Then how could we distinguish from it being an error or the value itself that we're returning? And to get around this, there's basically a simple way to do it, and that's just to add a second element here to the arguments that we're going to be passing to the pop function, and it's essentially going to be a pointer to a pointer data. And this is where what it's going to do, this pop function is going to take this pointer to a pointer, it's going to modify it, store the data that it's popping into it, and then when you get it back, the user is just going to have to read it from here and get the data from it. You could actually just use a pointer to a data, actually, a data of type int. But we're going to see why we're using it this way. You could simply use one star if you wanted to, so a pointer to a type int, and then your implementation will be slightly different, but it will still work. So this is what we're going to do. So this is where we're storing the data that's being popped, and this is our error code. So now we've solved our problem of prototyping of push and pop. And then creating a stack and deleting a stack is pretty straightforward. All you have to pass in is the stack itself. So a pointer to the stack, so we could delete it or create it. And I'll show you that in the next video. But yeah, we're going to stop here for now.